Hi, I'm Jeff Hancock with Blue Wave Ultrasonics, and we're going to talk a little bit about ultrasonic cleaning systems and how they actually work and clean parts. In an ultrasonic tank, we actually create what's called cavitation. And cavitation is millions of these imploding bubbles happening at any instant in time. They're invisible to the naked eye. You can't actually see them in the ultrasonic bath when it's operating, but this is really what's going on. And all the energy inside this bubble is what actually does the scrubbing and cleaning of the part. It's like I said, it's microscopic, so it gets in very intricate areas. Cleans much better than hand cleaning, line of sight type washers in intricate areas where, again, you just can't reach. So how does that work? We vibrate the bottom of the tank at an ultrasonic frequency using transducers. These transducers convert an electrical ultrasonic signal into mechanical vibrations, again at that ultrasonic frequency that we're operating at. So when we turn on the tank, we're actually going to vibrate the bottom of it 30,000 cycles a second in this particular system. What you're hearing there is the resonant transducers and the mechanical vibration that's going on. So again, you can't see that, but we can show the pressure waves that are actually coming off the tank bottom, which are required to create the cavitation process. It's not the pressure waves that clean the part. It's actually the cavitation process again, but you need the pressure waves, the alternating pressure waves back and forth to actually create the cavitation. So when I turn this ultrasonic tank on, what's going to happen is the bottom of the tank is going to vibrate 30,000 cycles a second. You can't see those pressure waves, but if I take this glass jar filled with glass beads and I place it in the ultrasonic tank, you can see the glass beads just bouncing. The reason that occurs is because the pressure wave is being sent through the solution, banging on the glass, bottom of the glass jar, and causing those beads to bounce. Okay, so we showed how the pressure waves transmit through the solution, but again, it's not the pressure waves that actually do the cleaning. It's the cavitation process that's created by the alternating pressure waves in the solution. If I can show the cavitation, if I coat this ceramic ring with simple pencil lead, graphite, now if I put it in the ultrasonic tank with nothing going on, and I agitate it back and forth, you'll see that it doesn't come off at all. Okay, but if I turn the ultrasonics on, you'll see it's only seconds before that graphite is completely removed. Now, as we mentioned, the cavitation process is invisible to the naked eye and it cleans extremely intricately. We showed how it removes the graphite off the ceramic ring. But if we do that again, coat the ring, and if I put another ring on top of it and I hold them together, turn the ultrasonic tank on, you see the graphite actually being driven out between those two flat surfaces. So we talked about how the process works, and now we're going to talk about how it relates in a real-world application. In the ultrasonic cleaning process, the chemistry that you use is extremely important. Depending on the contaminant type, the concentration of that chemistry is important. The temperature of the solution is also extremely important. There's things that you can do at 160, 170, 180 degrees Fahrenheit with the same solution that you could never do at 120 degrees or 130 degrees. So it's critical that all those parameters are right. This particular part that we're going to clean is a part of a cutting tool assembly. You actually see the inserts inside. and it's very contaminated with heavy cutting fluid, chips, and so forth. Okay, so we're going to put this part in a basket and place it in the ultrasonic tank. You can see not much is going on, but I'm going to turn the ultrasonics on, and you can see it blasting away the oil, the grease, the chips, driving out the intricate areas between the actual insert and the body of the cutter wheel itself. So about 5 minutes later, you pull the part out. It's detergent, so we want to rinse it off. Hit it with a quick blast of compressed air. And there you have it. So again, ultrasonic cleaning and the proper chemistry, concentration of the chemistry, temperature and time is a great way to clean parts very intricately and thoroughly.